Welcome to the Crazy Hat Chemist. So another video on gases. Bam! So today, how dense are you? So what is the molar mass of a gas with a density of 0.00249 grams per milliliter at 20.0 degrees Celsius and 744.0 millimeters of mercury? So what we're going to be using is the ideal gas equation. We could use the density equation, that's density equals PM over RT. That will work perfectly fine. Or we could always refer back to the original equation, and that's the ideal gas law, which is PV equals nRT. So keeping that in mind, we're going to always use the gas constant, and the gas constant has specific units associated with it. So I'm going to take all these units that I've got here and put them into the correct units for the gas constant. So this is why I'm converting the millimeters of mercury, which is pressure, into atmospheres. So I have 744.0 millimeters of mercury. I'm going to convert that into atmospheres. The 1 in front of the atmospheres and the 760 in front of the millimeters of mercury, those are unit conversions, so both those have an infinite number of significant figures. So I'm going to maintain the same number of significant figures in the 744.0 that I had before, which is 4. That's why my new pressure with the new units are 0.9789 atmospheres. Okay, I'm going to do a similar thing here now for temperature. Except for temperature, I'm starting off with 20.0 degrees Celsius. I'm going to add 273.15. I'm going to get 293.2 Kelvin. Again, I'm using the fewest number of decimal places when you're doing addition subtraction problems. And the 20.0 is significant in the 10th column. Therefore, the 293.2 is significant, the 0.2 is significant in the 10th column as well. So I'm still maintaining the same precision in the temperature that I had originally. Okay, now I'm going to convert my density into a new density with different units. So I'm going to convert the density, which is in grams per milliliter, and I'm going to convert it to grams per liter. And so all I'm going to be doing here is converting the milliliters into liters. And the unit conversion for this is 1 liter is equal to 1,000 milliliters. And in the 1 in front of 1 liter is an infinite number of significant figures. And the 1,000, there's an infinite number of significant figures in the milliliters because those are both unit conversions. And now I will have 2.49 grams per 1 liter. All right, so I'm going to keep on going with this. I'm going to use the ideal gas equation right here, and I've rearranged this already like I did in the 2 previous videos, and I've solved for the number of moles. So N is the number of moles, P is for the pressure, V is for the volume, R is the gas constant, T is the temperature. So I'm going to plug in the gas constant first. That's 0.0821 liters atmospheres moles over Kelvin. Then I'm going to plug in the temperature. I rearranged that and solve for the Kelvin. I'm going to plug in the pressure, of which I have, and I'm going to plug in the volume. That is, I got 2.49 grams per 1 liter. So what's my volume? 1 liter. Okay, so that's why I have all these numbers in these places right here. You should see that liters cancels out, kelvins cancels out, atmospheres cancels out, and then in the denominator of a fraction, I have moles, and then that's going to pop into the numerator, and I'm solving for moles. So this is a beautiful thing. So I'm going to solve for this moles, and I'm going to get 0.04067 moles of gas. Now I'm still trying to solve for the molar mass of this. Okay, and the molar mass has these specific units, which are grams per mole. So I've just solved for the moles, and I actually have the mass of this gas. The mass of this gas under these conditions that I have is 2.49 grams per 1 liter, remember? And then I have 0.04067 moles of gas. So I'm going to plug in those numbers as is appropriate with their specific units, and that's what I got. So I got 2.49 grams per 0.4067 moles, and I'm going to get this number here, 61.2 grams per mole. So that is the molar mass of the gas that I'm solving for. So that's how dense you are. Okay, now alternatively, you could have used this equation, density equals PM over RT. And you would have solved for the capital M, which is the molar mass. You just need to rearrange this equation here and get dRT divided by P, and that's the molar mass, and you could have plugged right into there, and you would have gotten the same number that I got here as well. And give that a try, see if that works out well for you. Okay? I am the Crazy Hat Chemist, and of course I got a crazy hat. I got a dinosaur. Okay? I'm not a dinosaur. I am so much younger than a dinosaur. So why don't you give me a thumbs up on that video and subscribe to my YouTube channel. I'll see you next time. Bye now.